Okay, question 4, we've got our complete the square question. So completing the square is all about rewriting this so that it's easier to find the turning point of the equation. So when we factorise, we're doing that so that we can see the roots more clearly. When we do our complete the square, so we can find the turning point. Because you should remember, if I've got something like x plus 2 squared plus 3, the turning point is negative 2, 3 from that 5. So we change this sign and this stays the same. Very similar to moving our graphs when we do the opposite of what's next to x, and outside the bracket stays the same. So do the opposite, negative 2 plus 3. So that's why we do this for a start. So they're quite nice. They give you the finished form. Okay, so you can see that there's a common factor been taken out, and then this is like a leftover. So first thing you want to do, I'll write it down, is we need it to be in the form of x squared. We don't want a number in front of that. So I need to take out 3. So it's going to give me x squared plus 8x, and then 50 just stays where it is. Okay, so again, there's a wee clue to that in here. And this is where a lot of candidates make a mistake. They start to kind of complete the square already. But no, we're just doing a common factor first. So I've got x squared on its own. Now, I'm going to half my x term. So, oops. X plus 4 squared. So this is me starting to complete the square now. I'm halving this term and my square comes outside the bracket. Okay. The 50 stays where it is. But what I need to do is take away the number that I generate from this bracket, which I do not want. So inside that bracket, if I was to break that out, if you go over here, okay, if I had x plus 4, I'm going to get x squared, I'm going to get 4x, I'm going to get 4x, I'm going to get 16. Now, x squared is looking good. I wanted an x squared term. And the 8x is also looking good. I wanted 8x. But I don't really want this 16. I just want to rewrite this, yeah? So I want to get rid of the 16. So I'm going to take away the 4 squared, which is 16. I'm taking away that 16. But that 16 is also multiplied by 3, because don't forget, this bracket here is not just x squared I wanted, it was 3x squared. It's not 8x, it was 24x. So I need to make sure I also times that by 3. So that's going to come out as 48. My final answer is going to be 3x plus 4 squared, 50 take away 48. So it's going to be plus 2. So I think when you do that, let's just double check. You're getting a mark for your common factor, first of all. You're getting a mark for completing the square in your final answer. So when you do this, make sure you get your common factor. Don't start doing the dividing too until you've done the common factor. That's a mistake. And also, check you've done it right. Multiply this out, and you should end up right back to where you started. Okay, so that's nice and easy. And again, the turning point for this, negative 4, 2. So if I wanted to draw this out, it wouldn't be too hard. Okay, so negative 4, 2 is up there somewhere. It's a positive x squared, so it's happy. There we go. So it's going to look something like that. So it helps us draw out the graph, negative 4, 2. Question B, and I'm just going to, I'll leave that off. Run out of space. I'll put it over here. So question B is just a simple differentiation question. So make sure you use the right notation, f dashed x in this case, because we've got an f of x. And you know, for these, I sometimes think to myself, okay, right, what's differentiation again? I always remember that x squared goes to 2x, because I'm multiplying this term and then taking away 1. So 2 comes down and 2 becomes 1. Okay, I've got that. Just to remind yourself, in case you start integrating accidentally, okay? 24x plus 50. And again, we clue in this question, they always try and tie this in with this because of the next question. So you should be thinking when you differentiate, oh yeah, that looks pretty good because I've just seen that. And again, nice wee 2 marks actually. You're going to mark for starting to differentiate and then to complete the differentiation. So nice wee, overall nice wee 5 marks. Yeah? And the last one, hence otherwise explain why this is always strictly increasing. Well, all that means is, does it have a positive gradient? Now, I just drew this out. That's x. This isn't actually y though. If this is the differential, which again we can read out differential like this is actually a dy by dx. So every number above the x-axis has got an m greater than 0, because these are all greater than 0, and everything below has got an m less than 0. So what it's saying is the differential is always in the positive section of the diagram. So therefore, we're always going to have a positive gradient, so for any value of x. But how do we write that for the SQA? Again, I'm not a marker, so I'm actually not sure if a sketch would suffice. But what we want to do is say, okay, well, if you look at this, I know that x plus 4 squared, that's always going to have to be a positive number, isn't it? Might be, could come out as anything bigger than 0. Yeah, it's always going to come out bigger than 0. Can't even come out as 0, can it? Well, no, it could come out as 0, because I could say negative 4 plus 4 is 0. Yep, so 0 squared is 0. So it's going to come out as bigger than or equal to 0, but that's as small as it's going to get. Okay, so it's going to do that for all values of x. There's a little symbol there you can learn. So for all values of x, yeah. So okay, what might come out is 0, but then if I was to multiply it by 3 and then add on 2, it's definitely going to be greater than 0 for all values of x. Now it's not even equal to 0, it's going to be greater than for all values of x. So I would just then finish off by saying, therefore, always strictly increasing. And it just means that you've got a positive gradient for all your values of x. So start off and build it up. This term here, at least that can be 0, but chances are it's greater than. So it's greater than or equal to 0. If I take that, multiply it by 3 and add 2, it's always going to be greater than 0. And then you've always got an increasing function, which you can prove with this. And I'm just checking the marking scheme now. I don't see anything about a diagram, but that's how if you want to visualize it that way to yourself, you can. But we're more interested in writing this kind of layout where we're talking about how the bracket shows that we're going to always end up with a positive number. So yeah, hope that's helpful.